Terraforming Scout Robot 746, or ROB for short, has been assigned to visit locations within the solar system to determine the potential for human resettlement. Although Earth has many years ahead before overcrowding becomes a major concern, it's important to plan well ahead and review what options we have before us. ROB is the 746th robot to study those options in depth. Terraforming, which is modifying the environment of planets to make them a lot like Earth, may take up to several centuries, so necessary evaluations are required to determine the best new world candidates. It's important to identify the risks, what resources they may provide, and what the cost might be to human civilizations. Someday billions of people will not only require locations to move to, but will ultimately need outposts and fuel depots as they venture further into space. As valuable resources are identified in every corner, more jobs will develop in many locations throughout the solar system. A new form of a gold rush will take place, and various types of resources will be mined for their lucrative gains. We will need more planets we can call home for this new advanced space age. All of ROB's robot predecessors had failed in their attempts to examine the planets due to extreme temperatures, gravitational issues, and other various unforeseen elements that damaged their inferior builds. But ROB has been built with a revolutionary plasteel material. This newly invented element, once constructed, cannot be broken. Its electronics are capable of withstanding solar radiation. The outer shell of ROB can absorb heat so incredibly hot that it could take a quick surf on the sun and remain functional. ROB begins at Mercury, the closest planet to the Sun. Its surface resembles that of the Moon. Hundreds of craters sit in the near distance, showing signs of asteroids peppering over the millennia. ROB walks along a long plateau of smooth terrain, grayish-brown in color, and finds himself beneath a large cliff 1 mile high, covering a distance as far as his robotic eyes can see. ROB has no interest in staying the night, as 1 full day lasts 58 Earth days. Music. The gravity is 30% of that of Earth's, making it enjoyable and more efficient to hop, covering long distances. No living thing would be capable of sustaining them. The magnetic field is impressive for the size of Mercury, but to be capable of terraforming, it would require support from an artificial magnetic shield. Mercury would also require this for an atmosphere to begin its development. With an abundance of oxygen and nitrogen, Mercury would form a solid atmosphere. During its atmospheric formation, large quantities of water will also be added. After an easy first destination, ROB arrives at Venus. Here, opposite atmosphere filled with thick carbon dioxide. All around ROB are thick yellowish clouds of sulfuric acid. But what it can see is dreadfully unappealing. Temperatures here reach as high as 900 degrees Fahrenheit. The alloys that make up ROB's outer body ensures it can withstand this test, and continues the mission. The pressure is so it would be equivalent to walking 3,000 feet under an ocean on Earth. It's difficult and a slow task for ROB to walk, but its powerful joints allow it to move unbending and creaking with each step. Reaching a high vantage point, ROB observes and identifies some beauty in this inferno land. The rolling plains, rusty in color, dozens of volcanoes in the distance with a flow of never-ending clouds of steam into the air. The volcanoes seem relatively quiet now, though they could still be active. It's clear that it would be impractical to place even an outpost on Venus at this time. The atmosphere is 100 times thicker than on Earth. Though millions of years ago it was very different, Venus may have once had a healthy atmosphere just like Earth's, but as time grew and the carbon dioxide could not escape, it created a constant build-up, heating up to the infernal environment that now persists. Terraforming Venus would require initially cooling it down. ROB believes a giant mirror to reflect the sunlight would possibly help once Venus has cooled down to the point. Its completely frozen carbon dioxide could be mined in its frozen form and then transferred away from Venus to be used elsewhere, or discarded. This procedure could take hundreds of years, as there's a lot of carbon dioxide to be removed, and then from there the solar mirrors could alternate to reheat Venus to when the temperature is just right. And Further elements like hydrogen may be added. This process would have to go on until the right amount of heat and atmospheric pressure is suitable for life to thrive. Rob moves onwards to the most visited planet in the solar system by any robot, Mars. Rob finds himself walking along, noticing some of its fellow broken down robots from years gone past. Partially covered in sand, neglected within the vast deserts, the iron oxide stained sand reminds Rob of deserts on Earth, though it's much colder here, with temperatures dropping to -80 degrees Fahrenheit. The day cycle here is almost the same as on Earth, but the amount of sunlight is only 60% compared to our planet. As Rob moves and jumps thanks to the gravity of only 38 of Earth's, it takes a good look around in the distance. It can easily notice Olympus Mons standing lonesome out there. It's the largest mountain in the solar system, 3 times the size of Mount Everest. Rob notes the ice frozen within the ground and water that has laid dormant since Mars was not too dissimilar to Earth. And the solar winds had stripped away its atmosphere. Just like Mercury, Mars will need a new, more powerful artificial magnetic field, constantly following Mars's journey around the Sun, sheltering and protecting it like an invisible umbrella. Once its atmosphere has the freedom to develop, Mars will be heated up, first heating the poles, focusing the Sun's rays with giant mirrors. As it heats up, the vast amount of carbon dioxide frozen in the ground will release, warming up the atmosphere faster and kickstarting the atmospheric process, growing warmer over the years. Eventually the ice will melt, forming rivers, lakes, and oceans. Water will provide the foundations for life to begin. But there will be plenty available from Venus if necessary, if the project is accepted and Earth finances Rob's estimation in full. The first colonists could arrive and breathe fresh air on Mars in 50 years. Rob passes by Neptune, Uranus, Saturn, and Jupiter. None of the gas giants can be considered as options for terraforming, but some of the moons around them could be counted as candidates for terraforming in the future. Callisto, Europa, Titan, Io, and Ganymede are all great potentials as Rob flies by, but the Scout will have to return another time as it approaches the last location on the list, the dwarf planet Pluto. It is technically possible to terraform, though they would need a vast amount of power to warm up the atmosphere, years of constant energy. The ice would melt, providing a dwarf planet full of water if it turned out to be successful after centuries of resources spilled into the transformation. So any vegetation to be grown would need assistance through artificial lighting. The number of resources required to terraform Pluto would be wasteful, not to mention the amount of time it takes to travel from Earth. Pluto would be much better off as a mining outpost. The ice water will be a great commodity for the more habitable locations. Rob is content with a review of our solar system. Ultimately, Mars is the most likely of all the locations, but given that they will all require a lengthy development period before they will be capable of sustaining life, there's no reason why work cannot commence on all of them, even on Pluto or the many moons surrounding the other various planets and the asteroid belt. There are valuable resources in all sections of our solar system that will be of great benefit to wherever we humans plant our feet.